because you know that the basic...
now we actually see visual from the
ground. This is an infrared video image from the ground station. We can see the bright spot is a re-entry capsule. We can see the long trail is, as Professor Zhang has already mentioned, is the plasma produced by the high temperature.
So is this in atmosphere now, the return capsule?
It's already in the atmosphere.
Yeah, because we can see the long trail now, right? Yeah. Oh, the capsule is in the blackout zone. So for this stage, we cannot see live feed out from the capsule itself.
Well, you wouldn't see the videos even after the separation because the antenna is on the service module.
Right.
But now even the radio is cut off.
Look, you can see that just
the bigger, brighter
the beautiful view is the debris of the propulsion module, because it do not have a heat protection. So it will break into pieces with a
burnt out in the atmosphere.
And burn out. So this is like a meteor shower. So it's very beautiful.
Yeah, quite an exciting moment. So this footage is from a ground observation, right?
Yes.
Okay. So what's the standard time calculation for the blackout period?
Oh, we just heard the voice. One ground station has already captured our Shenzhou spaceship. So usually from the orbit burn to the landing, usually we conduct to about 40 to 50 minutes. So it is a very long journey, more than 10,000 kilometers. You know that because usually for our Shenzhou spaceship, the normal return, we call this semi-ballistic or the semi-lift re-entry, because the symmetrical axis of the capsule, you know, the capsule is like a bell, so it has a symmetrical axis. Usually, it's have a deviation of the center of its mass from the symmetrical axis. So during the re-entry, there is an angle between its flight direction and the axis. So we will have some lift. With the control of the attitude of the re-entry capsule, we can control the direction of the lift and then adjust the landing point. So it is a controlled one. And we can, although you know that there are some deviations, but we can control with the control to close as possible to the theoretical landing point.
Indeed, and we're getting closer and closer to the landing of the Shenzhou 19 spacecraft. And for more on that, let's cross live to our reporter Li Shuang, standing by at the Beijing Aerospace Command and Control Center. Li Shuang, bring us up to date.
Well, hello again, Pan Dong. As we anticipate for the final landing of the Shenzhou 19 capsule, the responsiveness of the Beijing Aerospace Control Center is on full display. Earlier, we heard that multiple stations across China have spotted the capsule, and we also heard the captain of the Shenzhou 19 crew reporting back to the control center saying that their condition is stable. Now, that is obviously a very good news. What we're about to witness is the capsule re-entering the Earth's atmosphere, and as well as the aerial braking kicking in at about 10 kilometers, and also the deployment of the main parachute. Now, like I mentioned earlier, for the first time, the capsule will be landing in the eastern zone of the Dongfeng landing site. That obviously presents new terrain as well as new challenges. But the teams across the mission, from the engineers here at the Beijing Aerospace Control Center to the search and rescue teams out on the front, they're all working closely together to ensure that everything is ready. They've also run full rehearsal and deployed air and ground recovery team. They've also adjusted the plan with precision. Now, we learned from the final rehearsal that within minutes of receiving simulated coordinates from the Beijing Control Center, a helicopter swooped in to secure the landing area, and also nearly 100 vehicles, including command trucks as well as search and rescue units, also were deployed across multiple routes. Now, that is obviously something we're expecting to see shortly. What we're also expecting to see upon the landing is the ground teams opening the capsule and helping taikonauts out and swiftly transferring them for medical checks. Now, currently we're hearing a lot of real-time commands and receiving. We're seeing that the Beijing Aerospace Control Center is sending out real-time commands and receiving information from different stations. And now we'll be standing by here and closely following the descent of the capsule and bring you up to date. Back to you, Pandong.
Thank you very much. Our reporter Li Shuang in Beijing Aerospace Command and Control Center. So, gentlemen, let's talk more about this. I think we're still waiting for the return capsule to go through the blackout zone. Right. And after that, is it a step of opening the parachute, Professor Zhang?
Right, that will happen at around 10 kilometers above ground. So once they come out of the blackout zone, the intense deceleration will bring them down to like speed of an aircraft. That's still too fast to hit the ground with. So once the parachute is deployed, that will bring the speed all the way down to like 7 meters per second, which is brisk running. It will hurt. It's survivable, but it's not ideal yet. And then the last step is there's going to be a solid retro booster at the very end, 1 meter above ground, and then that will bring it down all the way down to 2 meters per second, and that'll be fairly comfortable to the landing.
Right, and just several minutes ago, we heard confirmation from the command center saying that the airborne team is already standing by at a projected coordinates, as you just mentioned, 101 longitude, right?
Yeah. Oh, great. We've already seen the deployment of the parachute. Look the beautiful view. So the main parachute has already been deployed. At this moment, it's already below, the altitude is below 10 kilometers.
10 kilometers, right.
So at this moment, we can say that the astronaut is already safe enough.
Yeah, and that, I guess that's partially why now this spot is looking much bigger.
Exactly.
Compared to earlier stages.
What you see is not the capsule itself.
It's a huge parachute. It's a huge
parachute. So the total area of the main parachute is more than 1,200 square meters. So you can how big it is. Bigger than the basketball field.
So I guess that's totally designed to the payload of the capsule itself, right?
Exactly. So at this moment, you know that. So that's what we mentioned about when we talk about the wind. You know that on yesterday, because there are very strong winds, so there will be very serious influence of the wind to the trajectory, especially after the deployment of the main parachute.
Yeah. Now, I think they've just disconnected the main parachute, right? And opening another parachute?
Sorry, I made a mistake. So that's the drag chute. So this is the main parachute.
Oh, this is the main parachute.
Exactly.
Okay, now obviously we can see this is optical. This is not infrared. So I believe if we are on the ground, with the sky is clear, and we can see that with our naked eye, right?
Exactly.
Yeah.
So this is a view, I believe this is a big camera, but also, as you mentioned, we can witness of the whole parachute and the reentry capsule with your naked eye.
Yes, and as it entails on the upper right corner of your screen, it says it's the optical signal.
So visible, the camera in the visible light band. And also, as we have just heard from the ground control, for the third time, they have the prediction of the coordinate of the predicted landing point.
Yeah, you have to be precise and have to adjust everything in real time so you can get there on time,
mentioned,
on place.
The prediction will be conducted 4 to 5 times to help the ground rescue team to get to the real landing site as soon as possible.
Right. Yeah, talking about size of this main parachute, you can see how big it is because
1,200.
Yeah, you would imagine a capsule is big enough because at least it has to hold 3 taikonauts and their necessary equipment.
Yes, exactly. Yeah. So you know that the total mass of the re-entry capsule is more than 3 tons. A big one. Although you look, it's very small, like bell. But still, for this re-entry capsule, we need a very big parachute because we use a single parachute. For the next generation, we call the next generation our spaceship, we will use multiple parachute because it will be connected for the lunar missions. So the re-entry capsule is much bigger than our Shenzhou spaceship.
Right.
So today, even
I'm talking about payload. Sorry, Professor. I'm talking about payload. Professor Zhang, earlier, of course, before the re-entry, we saw the disconnection of the propulsion module of the spacecraft itself. But talking about this return capsule we're looking at right now, talking about its payload, it still has some propulsion module or segments designed onto it, right?
It's for adjusting its aptitude, its orientation and stuff like that.
Right.
And then also the last sort of retro. They're really
to cushion
simple stuff.
the impact, right?
Yeah, they're not very powerful.
Nothing major, but got some.
Right, and they have few, and which is why soon-ish you will see them dumping the residual fuel because it's toxic. You don't want that to spill.
Right.
And
Yeah, it's about to land.
What
we just
what
heard
Professor
from
Zhang mentioned is called a monopropulsion system. It uses hydrogen. Hydrogen as a propellant. So the hydrogen is toxic. So before the landing, we must really, you will see a white fog maybe several seconds later.
Yeah.
So that
it's about to land
because
we just heard
all
from
of the propellants
yeah.
outside.
Yeah.
No, this is heating shield, the main heating shield. Because jettison is the main heating shield.
Right.
Because we, as Professor Zhang has already mentioned,
yes.
we need solid 4 rocket motors to continuously slow down vehicle when touchdown.
Yeah, now the heat shield is gone, right? So that signals the landing is quite imminent.
Exactly. So to expose the 4 rocket motors. And you know that even with this huge parachute, it's still too fast when touchdown. So that is the reason why we need 4 retro rocket. When is the distance between the vehicle and the Earth is about 1 meter, we will ignite the 4 rocket engines, and the speed of the vehicle will slow down to slower than 2 meters per second.
So the control could be that precise, just 1 meter above, with this 3-ton payload, just when it's only 1 meter, and the ignition will happen.
The ignition, very good question, very professional. You know that just on the bottom of our re-entry capsule, we have one device called gamma ray altimeter. So it will emit gamma ray to the ground, and with reflection, it have a receiver to measure the time. So we can have a very precise measurement of the distance between the bottom and the ground. So it will send signals to ignite the 4 rocket engines and will slow down the vehicle to, as mentioned, less than 2 meters per second.
Right, and that's automatic?
Yeah, this is completely automatic. And you know that after landing...
No, we're actually doing the altitude countdown right now, 4,000 and still decreasing.
So this is a parameter sent by the Shenzhou spacecraft to our ground center. So you can see the very precise measurement of the distance between the bottom of the re-entry capsule and the ground.
And you can, from the countdown, you can see that the descent is really, really fast.
And you may notice
that
we've
got to zoom in on the capsule.
We will deploy another rope, and attitude of the capsule will be changed a little bit from a lean one to a vertical one. So this is also to help the touchdown.
Sorry, is this in vertical mode right now? Because it looks straight up with the parachute on.
Yeah, so the parachute, the parachute bay is actually off an angle, which is why initially it was tilting a little bit. As Professor Yang was just mentioning, they have another rope to pull it up. So
now that's the discharge of the
the
fuel,
hydrogen.
Yeah.
Because it's
for safety precaution.
It's toxic, but it's necessary. You see that, as I mentioned, it is a controlled re-entry. So as Professor Zhang mentioned, we can control the attitude of the capsule during the re-entry. This is the function of the propulsion module, propulsion system on board the re-entry capsule, but only change the direction in the roll direction. To change the direction of the lift. With the change of the lift, we can change the trajectory to the landing point.
So it's not falling through atmosphere; it's flying through it.
Flying, yes.
And the engine is basically, as like the aircraft wings changing the flipping up and down.
Right.
It's doing that function.
Right, but so I believe for a high-stake mission like this, so a free fall is totally out of out of
only
option, right?
only in emergency. It
Oh,
can
right,
happen
right, yeah.
if they need to
Hope
get
that
down
never happens.
really quickly.
Yeah, hope that never happens. Oh.
It's designed to survive that, but it's
Right.
survive and being
Yeah.
comfortable.
Yes. Yes. That's what we call the redundancy design, right?
Exactly,
You
yeah.
always have
For
backup.
manned spaceflight, it's
Yeah.
necessary and
Yeah.
reasonable
Yeah.
to have sufficient redundancy
Yeah.
measures.
Yeah.
You know that always we think the life and the safety of our astronauts comes first.
Yeah.
So although you know that it need more resources, the mass, the volume, but very, very necessary. For this one, we have a backup parachute.
Indeed.
But you know that for the next generation, we will use, because we will use multiple parachutes. So each of the parachute can recognize as a backup and redundancy of each other.
Yeah.
So it will be necessary in the future to master
And
this
even
different.
with those automation process you just mentioned, we can still do a manual override, right?
We have manual operations. We have the buttons inside the cabin. In emergency case, the astronauts can do these kind of things. So that is reason the training is very, very necessary. You know that during an emergency escape, we will conduct the re-entry in what we call the ballistic re-entry. So the G-forces can be 8 times greater than their own mass.
Yeah.
Even at this
Impossible for common people like that.
as you mentioned, they must have the ability to do the right choice and press the button.
Yeah, with that kind of gravity.
Yeah.
Yeah, and no mentioning the pressure.
Yeah. Exactly.
Remember, they've been in zero gravity for 6 months.
Yeah,
So it
yeah.
feels double hard.
Oh,
yes,
So.
exactly.
Unimaginable. Now, we can see the descending is going on very fast. And earlier, I think we saw footage from the ground team, from the ground vehicles. They're also heading to the designated
landing point.
Yeah.
So we can have a very clear view of the parachute and together with the
Because it's getting closer and
capsule as
closer,
well.
right? We don't need to
Closer.
zoom like 100 times
Yes.
to take a closer look.
Yes.
Yeah.
So very beautiful. And you may notice the background is a blue sky.
Yeah.
Extremely beautiful.
Lovely weather, huh?
Yeah, so it's very, very clear. And today the weather is much better than yesterday.
Now it's only less than 2,000 meters from the ground.
Correct.
Yeah.
And so it is a reasonable choice to conduct the landing today better than yesterday.
Oh, of course. Safety is the utmost concern, right?
It's not even swinging that much, so the wind really died down. But since we're
That's
in Beijing,
absolutely good news, right?
yeah. Since we're in Beijing, we kind of understand weather's changed that quickly. But for our foreign,
Just
With-
from the
with
previous
these
video, you may notice that Mr. Song Lingdong is sitting just on the right side of the command Cai Xuzhe, and it is that Mr. Song Lingdong is called 02, and it is duty of 02 to cut the rope of the parachute when land. So if it is just in the right moment, the advantage is that the capsule will stand there vertically. It will be very convenient for the astronaut. But you can seldom see this scenario because you know that only during the Shenzhou 6 mission and during the Shenzhou 30 mission, the moment they cut down the rope is the right moment and they stand there vertically. But for other missions, they just the capsules lie down.
to a particular angle.
Yeah.
But that's the common scenario,
This
right?
is a common
Standing
situation.
upright is kind of exception.
Exactly.
Yeah.
But that's more convenient for the astronaut.
Yes, of course. Yes, of course. Maybe taikonnauts will feel much better,
Much better.
when
it's
the
its
capsule
center of
stand.
gravity is skewed
Yeah.
anyways, so it's not. It doesn't tend
So
to.
this is also the reason why we need the assistance of the ground team, especially the medics, to help the astronauts to have what we call the readaptation of gravity as soon as possible.
Yes. And the whole, the full recovery of your sense to ground gravity would take even much longer, right?
Yeah. At this moment, also there is another critical step to just raise the seats of the 3 astronauts. Because you know that to absorb the energy of the
Oh, since you
impact.
mentioned this, I must ask. Earlier you said it's the number 2 to cut the rope of the parachute. When you say cut the rope, you mean pressing a button or actually doing some standard maneuvers in that capsule to do that?
Well, you know that as we discussed, the wind is very, very dangerous for the whole landing procedure. And not only during the descending procedure, but also you know that after touchdown, the wind can be a big problem. So it can drag the whole capsule to a different place. So if it is in the mountain, it will be very, very dangerous. So it is necessary to
cut the rope.
Cut the rope.
You mean pressing a button to do the thing, or actually you
the
have to do a
problem
standard
is,
maneuver?
you know, that's, as I mentioned, the seats will be raised to absorb the impact energy. So the position of the bottom will be different when the seats are raised. So this is a difficulty and a challenge for 02 to conduct this operation. It will touch down soon.
Yeah, very soon. It's only about 500 meters above the ground.
But it is just pushing the button. It's not going to go out there.
No.
But
Impossible.
If it didn't manage to do that, somebody would jump off the helicopter and actually do that, cutting off.
At this right moment, the velocity of the capsule is less than 10 meters per second, but still too fast for the astronaut for the touchdown. So the retro rocket,
they've just adjusted the coordinates of the specific landing position.
They're just announcing. I mean, this is the fourth prediction.
And I believe the calculation is in real time, right?
Yeah, exactly. So the ground team, the whole ground team, will be guided by this prediction.
This is totally within approach if you're standing on the ground, right? Yeah. Really, really close.
Yes.
Wow. That's descending really
well. So the retro rocket will ignite soon.
So this is optical, right?
Yes, this is
from the helicopter.
From the helicopter.
Right.
Yeah, it's already above the re-entry capsule.
Yeah. Since you mentioned earlier, the terrain looks indeed a little bit different to
from the
common
part.
To the common landing site we've known.
Yeah. So it's more close to the Badan Jilin Desert in my homeland in Mongolia.
Oh, it's about to land.
Yeah. Oh, we can see the shadow.
Yeah. So cut the rope.
Ignition.
Oh.
Great.
Let's see if it's Now, the Shenzhou 19 return capsule has landed in Dongfeng landing site in northern China's in the Mongolia region again. This just happened. The Shenzhou 19 crew has returned to Earth 3 taikonauts are now on the ground in northern China's in the Mongolia region. So far, this has been a successful landing, right,
as you
gentlemen?
Mentioned, as we already discussed, you may notice that the rope connecting to the parachute has already been cut down.
Yeah.
So this is a very successful touchdown.
Yeah, and we can see the ground team is rushing their way to this specific landing spot.
Yes.
Yeah, but the aerial team is already standing by, right? We've seen aerial footage from the helicopter.
With this video, we can prove that the helicopter is very, very close to the capsule.
Yeah, and we captured, the last several stages of the landing.
Oh, this time still it's not a vertical van.
Yeah, but this is the common scenario,
it's the
right?
common.
Yeah, it's the common scenario. Yeah.
I believe the 3 astronauts are in good status. Oh, we can also see the shadow of the helicopter.
Yeah, and we got.
Already.
So we can tell that there's the helicopter. One helicopter has landed.
Yeah. Usually, after the ground team reach the capsule, first they will remove the radiation source of the gamma ray activator because it's hazardous to everyone.
Right.
So we will use a container made by lead and to protect the blockade radiation.
Yeah, and having said that, another helicopter has landed